Hello, and welcome to the Startup Track presentation of Polaris with Jia Li, Si Chen, and Nicholas Yang. In this presentation, we will walk you through what motivated us for starting Polaris, as well as how we see the competitive landscape. Then we will go through the use cases that we're currently building, as well as our looking to the roadmap of the future. And we'll talk about the architecture and design of those use cases. And then finally, we'll wrap it up with talking about the challenges that we have encountered. But before we jump into the details, we wanted to start out with an example that is currently in the news surrounding Facebook news feeds. Some people are arguing that fake stories found on Facebook that were popular in users' news feeds helped to influence the recent presidential election, something that Facebook itself denies. The argument stems from the fact that fake stories were circulating on Facebook about the candidates, and Facebook users couldn't easily decipher which stories were real and which ones were not. Since they trusted the Facebook system, they perhaps took fake information as real when making their candidate decision. Some people go even further, accusing Facebook of having no incentive to take down fake articles because any type of user engagement is good for them, regardless of the quality. Whether this is all true or not, it does raise a good question as old as the internet. What can you trust online? What you can and cannot trust online in general is a big question. It doesn't have a simple answer. At Polaris, we are focusing on analyzing and validating user-generated content in the form of user reviews of places and businesses. These online reviews are widely used by people to make decisions every day. Online review sites and user reviews start out as a way to give people a voice and share their thoughts with like-minded people and for other people to use this information in their decisions. But with so many sites hosting user reviews and so many users providing reviews, determining which reviews are real and can be trusted and which ones offer high-quality information can be a time-consuming and challenging task. Anyone can post a review, including owners, competitors, and even robots. An Italian magazine was even able to get a fake restaurant to be listed as #1 on TripAdvisor just to prove how easy it is to make fraudulent reviews on the site. We want to improve this space by providing a review rating and analysis system to help determine the quality and authenticity of reviews, as well as making it easier for users to interpret and discover useful information within the good user reviews. Restaurants and travel-related spending are opportunities that are in excess of $100 billion annually, and these markets are growing. Yelp and TripAdvisor make hundreds of millions of dollars annually through advertising to their hundreds of millions of users using their user review services. Being able to offer these consumers a way to be more informed before they make their decisions and spend their money with a sense of security is a valuable service to them. Looking at potential competitors, FakeSpot and Trustworthy seem to be the only other independent review analysis sites that offer fake review detection of user reviews, but they are focusing mostly on products that are offered by various merchants using Amazon Marketplace. They offer grades of review authenticity per listing on Amazon and do some summary of their analysis like best and worst product review list. User review sites themselves claim to have internal systems to monitor the authenticity of reviews and remove fake reviews and ban offending users. They also offer some level of review analysis and topic and phrase mining for each listing. As they are the owners of these sites, they have access to all the reviews as well as user accounts and click logs, putting them in a better situation than third parties to detect fraudulent and malicious behavior. But they do not release many details as to how well they are preventing fraudulent reviews. Strictly speaking, while wikis like Wikipedia and WikiTravel are not user review sites, they offer opinionated user-generated content that is another popular source of information for consumers and can also be lumped into a category of possible competitors.
For our use cases, we will first focus on fake review detection and topic mining with LDA. In the long term, we will add additional features, including recommendation based on similar reviews, review summary, and query cross-site reviews. In recent years, fake review detection has attracted significant attention. Yelp has been filtering suspicious reviews since 2005. The filtered reviews are not deleted but moved to the not recommended list on the website. According to a recent study, Yelp's filtering algorithm is reliable and seems to be correlated with abnormal spamming behaviors. TripAdvisor is another popular review site. A lot of travelers will end up on TripAdvisor when planning their vacation. TripAdvisor claims it can spot the fake reviews, but this is unverified. That is why we want to detect fake reviews on TripAdvisor. We will take a supervised approach as we can make use of Yelp's filtered review for training. We will label Yap's filtered review as positive and non-filtered review as negative and train a logistic regression classifier. We will use K-fold cross-validation to measure how well the classifier is doing. We found a research paper about fake review detection using Yap's review dataset. The paper proposed two feature types, n-gram features and behavior features. According to the paper, TF-IDF with unigram and bigram perform similarly, so we will start with unigram first. The paper proposed some highly discriminating spamming behavior features. Activity window is the difference of timestamps between the first and last reviews for that reviewer, and spammers are usually not long-time active members. The second one is the maximum number of reviews in a day because 35% of spammers posted all their reviews in a single day. Review count is the number of reviews a reviewer has. Because spammers are not long-time active members, they also have fewer reviews. Percentage of positive reviews can also be used because 85% of spammers have more than 80% of their reviews being positive. Review length is another one because a majority of non-spammers have higher average review length. Reviewer deviation analyzes how much spammers deviate from the general rating consensus, and most spammers have high deviation. Writing a new fake review every time is time-consuming, so majority of spammers have a lot of similarity across their reviews. According to the paper, the behavioral features significantly outperform the n-gram features. We will also use the percentage of positive and negative words in the reviews as features. This is how fake review detection works. We will have a separate process to train and update our logistic regression classifier using Yap's data. User first submits a request to analyze a hotel or restaurant. Then we will fetch all reviews and reviewers' information. We will extract features described in the previous slide and use our logistic regression classifier to detect fake reviews. Then we will present the results to the requester. The requester can also provide feedback for us to update our model. The other use case is topic mining with LDA. This can help users to understand better what is being said in the reviews of a particular business, help them see the common words and phrases, and see if there are any patterns in the reviews. They can also filter down the reviews to a particular popular term. It is easy to train an LDA model in Spark. The image on this slide is a code snippet we have to extract features and train the model. There are some challenges using LDA. Some listings might have a small number of reviews, and we need to figure out how to determine the number of topics for each listing business. The workflow for topic mining is similar. The user first submits a request. Then we fetch all reviews and run our Spark job to extract features and train the LDA model. Once we got the results back, we'll present it to the requester. The user can then drill into reviews by clicking a term. This is how we are building out the system. We are using Spark as our data processing and analyzing tool. It has many built-in functions for feature extraction, and we are using its machine learning library for review classification and clustering. We will fetch TripAdvisor's reviews as parallel jobs in Spark to speed up the process. All review data will be stored in Azure Blob Storage, which is HDFS compatible. We already have a program to crawl the Yelp and TripAdvisor's review data, but if time permitted, we will set up Apache NiFi as our data collection and ingestion tool. We can use it to build our Yelp review crawler data flow to collect new reviews as training data every day. Airflow is a platform to programmatically create, schedule, and monitor workflows. If time permitted, we will use it to schedule and re-execute the Spark job to update our logistic regression model after new Yelp reviews are ingested into HDFS. We are building a web application so users can interact with our system. We are using Spring Boot and AngularJS with MongoDB as our database to store additional information. We will deploy the application to Azure App Service. Our web application needs to be able to communicate with the Spark cluster. Lively is a service that enables easy interaction with a Spark cluster over a REST interface. It enables easy submission of Spark jobs and synchronous or asynchronous result retrieval.
After the initial use cases are built and more data is collected, we have plans to add additional valuable services to our system. These include providing recommendations to users to discover new content. One possible way to do this is to find and match up like-minded reviewers by linking reviews that are similar with regards to style and wording. Then users could enjoy reading reviews about other listings written by similar writers to themselves and discover new content. Review summaries is also another interesting area where we can look at providing topic mining and authenticity scoring across reviews from multiple sites as more reviews are collected and analyzed, giving users an aggregated view of listings in higher level spaces like cities, regions, and cuisines. Again, as more reviews are collected, providing a query interface to search reviews across sites and topics in a single place can be a valuable option to simplify user search and discovery.
We have built a web-based application to run and analyze the review dataset. It can help the user to understand the reviews better. There are 3 web pages. The first one is the home page. It is to simply introduce how to use our web. And we have a Yelp search page. It connects to the Yelp API to search for business by locations, keywords, and categories. For each restaurant, we have a business detail page. We run the analysis on its reviews in the backend, and the results will be returned and displayed in the front end. We'll show the results to the users, like the LDA topic model results. We'll return a list of top ranked words in the distribution. And the sentiment analysis is to create a word cloud to help users to visualize the sentiment information in the reviews. The fake review detection can help the user to detect which kind of reviews are more likely to be fake. We'll give a demo to show this. This page connects to the Yelp API. It has a searching function by locations. Suppose we want to find the restaurant in Las Vegas. It returns the information of a list of restaurants. And on this detail page, it has the review analysis result, including the topic model of the reviews. So these are the top ranked words in the distributions. And it also returns these fake review detections. So the users can find out which kind of reviews are more likely to be fake. We'll implement this function in the next week. There are 7 challenges in our project. The first one is lack of API to retrieve the reviews. Although we use Yelp API in our project, but it only returns a snippet text of the review. So we wrote our own functions to crawl the data. But there are several problems with this. The first one is that crawling hundreds or thousands pages takes a long time because we need to wait for 5 to 10 seconds in between page clicks. And also we might get blocked due to some crawling policies of the websites. The second one is we don't have evaluation datasets for the fake review detection. Since the topics and fake review detection are unsupervised learning methods, we don't have a set of labeled data as a benchmark at the moment. So we are thinking about that the initial evaluation criteria to start with is the user engagement, which can be measured by unique user site visits, total number of site visits, and we can also ask the users to evaluate the results as a feedback. As we gather more and more data, we can create our own evaluation datasets. We also need to improve the performance for collecting data when the user submits new analyze request. We need to make this more efficient. And the Spark cluster is very expensive. It takes more than $2 for one work node. This can be another challenge for us. These are the references.
Thank you for listening.